Today we are going to start Chapter 3. We'll be doing sections 3.1 and 3.2 in your book. First, we're going to start with some vocabulary words. Parallel lines are coplanar lines that do not intersect. The word coplanar is very important in this definition. In order for lines to be parallel, they must be able to be in a plane together, like lines JK and LM. Both of these lines can be contained in one plane that I could draw around them. If you remember from algebra, parallel lines have the same slope, which we can think about in geometry as pointing in the same direction. To show parallel in a picture, we use arrows inside the line. Lines that have the same number of arrows, like JK and LM, can be considered parallel to each other. The symbol for parallel looks like this. This sentence right here reads, line JK is parallel to line LM. Skew lines are lines that are not coplanar. Notice the difference between lines L and M in these pictures and lines JK and LM. Like we said, I can draw a plane around these two lines that would contain both of them. But since lines L and M are moving in different directions, there is no plane that can contain both of them. And therefore, even though they don't intersect, they are not parallel, they are skew. Parallel planes are simply planes that do not intersect. Any planes that don't intersect each other are considered parallel. To help you understand parallel lines and parallel planes and skew a little bit more, go ahead and do the activity on this page. Alright, now we're going to go over another vocabulary word, transversal. A line that intersects a system of two or more lines in two different places is called a transversal. Here's some examples of a transversal. Here are two lines, and a third line that's intersecting those two lines in two different places. That green line is a transversal. Here are some other examples of transversals. Now remember that it could be a system of two or more lines, and these examples only show systems of two lines and a transversal. Also, it appears that our two lines are parallel in each of these cases. That does not have to be the case. A transversal can intersect two or more lines, and those lines do not have to be parallel to each other. I will draw another example here of a system of lines and a transversal. Here I have three different lines, and this green line will be my transversal. Notice that the green line is intersecting each of the other lines in a separate point. This that I'm going to draw now is not an example of lines in a transversal. If I have two lines and a line that intersects them both in the same point, this is not a transversal. In order for a line to be a transversal, it must intersect the two or more lines in different points. Notice that these two lines are not parallel, but the green line still is a transversal. This is because it intersects these two lines in two different points. When you have two lines and a transversal, you get 8 different angles. Pairs of angles in this picture have certain names. Now remember, the pairs of angles that we're going to talk about here can only exist when you have two lines and a transversal. So none of the pairs of angles that I'm going to mention now are linear pairs or vertical angles, since linear pairs and vertical angles can exist without a second line. Linear pairs and vertical angles can exist when we just have two lines intersecting. To make these pairs of angles, you need 3 lines intersecting, 2 lines and a transversal. Notice when I have two lines, Q and R, and transversal T here, there's an interior part of the two lines, this green shaded area, which is inside these two lines, Q and R, and an exterior area, outside lines Q and R. Then we have angles that are on the same side of transversal T and angles that are on alternate sides of transversal T. This is important to understand when we talk about the definitions of these angle pairs. So angles 3, 4, 5, and 6 lie in the interior of lines Q and R. Angles 1, 2, 8, and 7 lie in the exterior of lines Q and R. So first we're going to talk about consecutive interior angles. Consecutive interior angles are in the interior part and are on the same side of the transversal. Angles 4 and 5 are in the interior of lines Q and R and are on the same side of transversal T, so they are a pair of consecutive interior angles. The same for angles 3 and 6. Alternate interior angles are exactly what their name says they are. They lie in the interior of the two lines, but are on alternate sides of the transversal. Angles 4 and 6 are in the interior of lines Q and R, but are on alternate sides of transversal T, since 4 is on the left side and 6 is on the right side. 3 and 5 are also another pair of alternate interior angles. Alternate exterior angles are also what their name says. They lie in the exterior of lines Q and R and are on alternate sides of transversal T. Angles 1 and 7 are a pair of alternate exterior angles because they lie in the exterior of lines Q and R, and angle 1 is on the left side of transversal T, and angle 7 is on the right side of transversal T. Angles 2 and 8 are also a pair of alternate exterior angles. Finally, we have corresponding angles. There are 4 pairs of corresponding angles. Corresponding angles lie on the same side of the transversal, and one is in the interior of lines Q and R, and one is in the exterior. For example, Angle 1 and angle 5 are a pair of corresponding angles because they are both on the left side of transversal T, but angle 1 is in the exterior and angle 5 lies in the interior of lines Q and R. Angle 2 and 6 are also a pair of corresponding angles. Angle 3 and angle 7 are a pair of corresponding angles. And finally, angle 4 and angle 8 are a pair of corresponding angles. Now we're going to look at what happens when we have two lines and a transversal, but those two lines are parallel.